Hello, I am Geeta Babu Singh, Assistant Professor in Electronics, Government Degree College, Kalaburgi. I am welcoming you all for today's session. In previous session, we discussed on TCP/IP, Internet addresses, and repeaters. In today's session, we discuss on bridges and types of bridges. Let us see what is bridge. So, a bridge operates in both the physical layer and data link layer. As a physical layer device, it regenerates the signal it receives. As a data link layer device, the bridge can check the physical address, that is MAC, source and destination contained in the frame. So, the bridge is equal to repeaters plus functionality of reading MAC addresses. So, as in definition, we are saying as a physical layer device and as a data link layer device. So, the bridge is a two-layer device. It also used for interconnecting two lanes on the same protocol. So, let's see what is the difference functionality between a bridge and a repeater. A bridge has filtering capability. It can check the destination address of a frame and decide if the frame should be forwarded or dropped. If the frame is to be forwarded, the destination must specify the port. A bridge has a table that maps addresses to port. So let's understand a bridge connecting two lanes. In this slide, we have the two lane connections. That is, the two lanes are connected by a bridge. If the frame destined for a station that is 7128134561 and 412 arrives at the port 1. The bridge consults its table to find the departing port. According to its table, frame for 712813456141 to live through the frame 2. Therefore, there is no need for forwarding and the frame is dropped. On the other hand, if a frame for 7112B13456142 arrives at port 2, the departing port is port 1 and the frame is forwarded. In the first case, lane 2 remains free to traffic. In the second case, both lanes have traffic. In our example, we shows a two-port bridge. In reality, a bridge usually has more ports. Note also that a bridge does not change the physical address contained in the frame. So next, bridge there are two types of bridges. First one is your transparent bridge. These are the bridge in which the stations are completely unaware of the bridge existence. Reconfiguration of the station is the unnecessary even if bridge is added or removed from the network. So that is, the transport bridge is a bridge in which the stations are completely unaware of the bridge's existence. If a bridge is added or deleted from the system, reconfiguration of the station is unnecessary. According to IEEE 802.1d specification, a system equipped with the transparent bridge must meet their criteria. That is, first one is frames must be forwarded from one station to another. The forwarding table is automatically made by learning frame movement in the network. Third is loop in the system must be prevented. So what is forwarding? A transparent bridge must correctly forward the frames. And what is learning? The earliest bridge had forwarding table that were static. The system administrator would manually enter each table entry during bridge setup. Although the process was simple, it was not practical if the station was added or deleted. The table had to be modified, which is not a rare event. For example, putting in a new network card means a new MAC address. A better solution to the static table is dynamic table that maps addresses to port automatically. To make a table dynamic, we need a bridge that gradually learns from the frame movements. To do this bridge inspects both the destination and the source addresses. The destination addresses is used for forwarding destination. The source address is used for adding entries to the table and for updating purposes. Let us see this. In this slide, we have the block diagram of a learning bridge and process of learning. So that is, in figure, we have a station A sends a frame to station D. So as shown in the slide, we have this station A which sends a frame to station D. The bridge does not have an entry for either D or A. The frame goes out from all three ports. The frame folds the network. Floats. At the source addresses, the bridge learns that station A must locate on a lane connected to port A. This means that frame destined for A in the future sent out through port 1. The bridge adds this entry to its table. So as shown in table 1, that is addresses and ports. In as shown in table B, that is after A sends a frame to D. So when and in table C, after E sends a frame to A, and table D, that is after B sends a frame to C. So when a station E, as shown in the block diagram, when this station E sends a frame to station A, the bridge has an entry for A. So it forwards the frame to port 1. There is no flooding. It uses the source address address for the frame A E to add the second entry to the table, that is as um, shown in this shown in the table C. So when the station B sends, as shown in the block diagram, when station B sends a frame to C, the bridge has no entry for C. So once again, it flowed the network and adds once more entry to the table. The process of learning continues as bridge forward the frames. Next one is, as I told earlier, bridges have there are two types of bridges. One is our transparent bridge and second one is source routing bridge. So the source routing, in this bridge, routing operation is performed by the source station and the frame specification which route to the flow, that is a transport bridge duties include filtering frames, forwarding and blocking. In a system that has source routing bridges, their duties are performed by the source station and to some extent the station destination station. In source routing, a sending station defines the bridge that the frame must visit. The addresses of these bridges are included in the frame, or in other words you can say the frame contains not only the source and destination addresses but also the addresses of all bridges to be visited. The source get these bridge addresses through the exchange of special frame with the destination prior to sending the data frame. Source routing bridges were designed by IEEE to be used with token ring lane. These lanes are not only common today. Thank you.